Good day. So there is what you call free fall, right? So what is free fall? So free fall is when there is no other force acting on an object except the gravitational force, right? So if they ask you to define free fall, you will say free fall is when there is no other force acting on an object except the gravitational force. So let's say an object is falling, so there's no other force, there is no air pressure or anything, right? The only thing that is acting on an object is the gravitational force. So hence it's falling. It's not resting on a surface. If it was resting on a surface, the surface was also going to exert a force upwards, right? But now it's not on a surface, right? It is falling, right? The only force acting on this object in this case is the gravitational force, right? So there is no air resistance and stuff. So mostly in metric, the situations that they give you, there is no air resistance. So you can also say it this way. You can say an object is on free fall if the only force acting on the object is the gravitational force, right? So this is all. So it's quite easy to define it. So when an object is on free fall, right? Let's just say an object is on free fall. So if an object is on free fall, there is what you call acceleration due to gravity. So when it's close to the surface of the earth in free fall, whenever I see the topic called vertical projectile motion, just know it's close to the surface of the earth. So it's accelerating when it's falling, right? So something can let's just say somebody jumps out of a helicopter. If somebody jumps out of a helicopter, this person starts at 0, right? Then his speed starts increasing. He keeps on accelerating. So now there's what you call terminal velocity. Terminal velocity is the maximum velocity reached when something is on free fall. So that is why a rat, let's just say a mouse, right? A mouse can be thrown from 10th floor, right? Or rather dropped from 10th floor. And the mouse will survive still when it reaches the ground. Why? Because the mouse doesn't take long time to reach its terminal velocity. Its terminal velocity is little, right? So it reaches its terminal velocity quick, and it's not a high speed. So it will be falling for that consistent speed until it reaches the ground. Imagine if you were to fall slowly until you reach the ground. You will not get damaged, right? It doesn't matter the height you fall from. But unfortunately, human beings have got a high terminal velocity, so they will keep on accelerating until they reach that terminal velocity, which is seriously high, right? So when they reach the ground with that terminal velocity, they eventually get crushed, right? So terminal velocity is the maximum speed that an object can reach while it's on free fall, right? So different objects has got different terminal velocity. So they won't go that much deeper on your syllabus, right? So that's what you call terminal velocity. Now when something is accelerating, it's accelerating near the surface of the earth, is accelerating by 9.8 meters per second squared. So you just memorize this. This is what you'll be using. So we won't be using it as A, right? We'll represent it by using this symbol G, right? So we use G to represent acceleration due to gravity. Alright, so now I'm going to show you all the examples when it comes to free fall, right? When it comes to vertical projectile motion. Here is a question. A ball is dropped from a building which is 50 meters high, right? Calculate the velocity of the ball when it reaches the ground. Now, when the ball reaches the ground, of course we know that it will stop, right? But don't say velocity is 0. That's not what they're asking for. They're asking for the velocity at which it will strike the ground, right? We want that speed that it will strike the ground. It will strike the ground with a certain speed, right? With a certain velocity. So they want the velocity with which it will strike the ground, right? Where it will hit the ground. So just before it stops, it will hit the ground with a certain velocity, right? So hence we'll hear that sound because it hits the ground with a certain velocity. So we want to calculate the speed. So we have a building, right? Now they say the ball is dropped, right, from a certain building which is 50 meters high. So I took this kind of example from Solutions for All textbook, right? So the ball is dropped from the building, right, which is 50 meters high, and then it will strike the ground after some time, right? Now what they want here is the velocity of the ball with which it will strike the ground. So before we answer this question, we have to look for the things that are given, right? So basically what we're looking for is either acceleration or time or the initial velocity or the final velocity or the displacement, right? It's usually represented by delta x, but because we're dealing with, remember, x is horizontal, right? But now we're dealing with vertical projectile motion. So now instead of us using x, we're going to use y, right? Because it's vertical, right? It's just like x-axis and y-axis, right? In the Cartesian plane. So we're looking for either of these things, right? We're looking for acceleration or time or initial velocity or final velocity or displacement. So we need at least 3 of this. If we just have 3 of this, then we can use the equation of motions, right? One of the equations of motions. So let's look for what are given here. So a ball is dropped from. Now when you look at this word dropped, there are some things that are indirectly given, right? If they say something is dropped, it means the initial velocity is 0. That was indirectly given. So we are given vi, which is 0, right? So this is indirectly given. So when something is dropped, its initial velocity is 0. It starts at 0, right? Now if something is thrown, if it says it's thrown, then we know the initial velocity is not 0, right? It means the initial velocity is not 0 when something is thrown. But in this case, it's dropped, right? Another thing that is indirectly given is this. If something is thrown upwards, when it reaches its maximum height, the final velocity is 0 because it will go up, right? It will start slowing down until it finally reaches 0. When it reaches 0, then it will come back down and it will land at the same speed at which it was thrown upwards, right? So what is indirectly given is that the final velocity when something reaches its maximum height is 0, right? So they don't have to tell you that, it's indirectly given. So whenever something is thrown upwards, just know whenever it reaches its highest point, its final velocity is 0, right? Just before it comes down, it goes up, then it stops, then it comes down. So when it stops up there, it's not moving, right? The final velocity is 0 at that moment. So it's thrown up at a certain velocity, then it starts slowing down until it reaches its final velocity, which is 0, and then it comes back down at the same speed. So if you throw something up, right, it will reach, when it comes back down, the speed will be the same as when you threw it up. So now here's another example. Let's say you take a gun and you shoot upwards, right? That's what I don't trust these people who shoot up. The bullet will go up at a certain high speed, right? And then it will reach a certain point at a very high distance and its velocity will be 0. Then it will come back. When it comes back to the point where it was thrown, right, where it was shot, it will actually come back with the exact same speed at which it was thrown, right? So if it lands on the person, unfortunately, the person gets killed, right? Because the bullet will come back at exactly the same speed at which it was thrown, right? As which it was shot, actually. So whatever you throw upwards will come back down at exactly the same speed. Alright, so let's solve this stuff, right? So we are given initial velocity, right, which is 0 because it says it was dropped, right, from a building which is 50 meters high. So we're given distance, we're given initial velocity. Then they say calculate the velocity of the ball when it reaches the ground. We need one more thing, right? Remember, we need to find 3 things. So we're given the initial velocity, right? We're given the distance, which is 50 meters, right? Now we need one more thing. Whenever you see that no other information is provided in the question, it means there is something that is indirectly given. So what else is indirectly given? The last thing that is usually indirectly given is the acceleration. We know the acceleration due to gravity is always 9.8. Oh, and I didn't even include it here, right? I did include it actually, but I wrote A, right? But remember, in this case, we represent it by G, right? So we're looking for either one of these things, right? We need at least 3 of them to be able to solve. So we're given the acceleration. So the acceleration, which is J, is 9.8, right? Now before we start solving, we have to choose our directions, right? So I'm going to choose down as positive, because it was on a building and it was just dropped and it's going downwards, right? So I'm just going to choose down as positive. You can choose up as positive, so I'm going to choose down as positive. So if I choose down as positive, it means everything that is downwards is positive. So my displacement is also positive, right? My acceleration will be positive, because acceleration is always downwards. Whenever, even if something were to be thrown upwards, it will start slowing down because it's accelerating downwards actually, right? When something is accelerating backwards, it slows down, right? So that means the acceleration would be negative. Let's say we choose upwards as positive, acceleration will be negative because it's downwards. So whenever acceleration is in the opposite direction of motion, right? Let's say something is moving to the right and acceleration is to the left, that thing will slow down, right? So let's begin to solve this thing. Vertical projectile motion is simple, right? We just need to find the three things that are given, either directly or indirectly, and then choose one of the equation of motions that has got those, right? So we're given this, and then we're asked to calculate the velocity of the ball when it reaches the ground. So that's the final velocity. So it starts at 0 when it's dropped, right? It will reach the ground at a certain velocity. So that velocity is what we're looking for. So which is Vf, right? The final velocity. So now we have to look for the equation of motion that has got all these four symbols, right? Because usually when we solve equations of motions, vertical projectile motions, what we need is three things that are given and one thing that we're looking for. And then we look for the equation of motion that has got all the four symbols. For instance, I'm given Vi, I'm given delta y, I'm given acceleration, and I'm given Vf. So I need to look for the equation of motions that has got all these four symbols that I just wrote down. I wrote down three of which I'm given and one of them which I'm looking for, which makes it 4. Now I want the equation of motions that has got 4 of these symbols, all 4 of these symbols. If one of them is missing, it means I can't use that equation of motions. So let's look for the equation of motion. And I noticed that Vf that I wrote wasn't showing down there, right? So Vf, which is unknown, right? It's what we're looking for. They ask for the velocity with which it strikes the ground. So we have three things that are given and one thing that we're looking for, right? So we need the equation of motions that has got all 4 of this stuff. Alright, so here are the 4 equations of motions, right? So we have got 4 equations of motions. Now we need to choose the one that has got all these 4 symbols, right? 3 of which are given and one which we're looking for. So this one has got Vf, as we see we have Vs there, and it has got Vi, we have Vi, and then it has A, right? We've got A, I wrote it as G, which is 9.8, right? But it has got T and it doesn't have Y, so we can't use the first one. So what about the second one? The second one has got Vf, of course Vf, Vi, we have Vi there, and A, we've got A, delta Y, yes, we've got delta Y, so it has got all 4 of them. So we know this one is the correct one. And of course the others will not work, right? Yeah, the others obviously will not work, so it's only this one. If it happens that the other ones work, then it means you can choose the one you want to use. Yeah, but I have actually never seen that. Yeah, I haven't seen that as yet. So we're gonna use the second equation to calculate. So let's start substituting. So our Vf, which is what we're looking for, so I'll keep it as Vf, right? Vf squared is equals to Vi. Now our Vi is 0. You still have to indicate 0 squared because they give you marks for substitution, right? And then times 2, our A is the acceleration, right, which is 9.8. And then our delta Y, so our Y is the distance, which is 50 meters. And then of course this will give you 0, right? So now we're going to have Vf squared is equals to, if you type this in the calculator, it's going to give you 980. And then from here you now have to square root both sides because we're solving for Vf, right? So we're going to have Vf is equals to, it's going to be 31.30 meters per second, right? Now you have to specify the direction because velocity is vector and not scalar, right? Vector meaning it's got magnitude and direction, so it has got both of them. So what you do in this case, so it has got both magnitude and direction. So velocity is vector, so we got the magnitude, right? We need the direction. Remember we chose down as positive, whatever is going down is positive. Now since our answer is positive, it means it's going down, right? If our answer was negative, we would say it's going upwards. So yes, we specify our velocity there. Here is another question. I made it similar to the question in Solutions for All. So it says a ball is thrown vertically upwards at 20 meters per second, right? Which means at a velocity of 20 meters per second. So a ball is thrown vertically upwards at 20 meters per second. Then they ask you to calculate the maximum height the ball will reach. So if you throw it, the ball is being thrown vertically upwards at a certain speed, right? It cannot be thrown without a certain speed, or else it will not even go upwards, right? So it has to be thrown at a certain speed upwards, so that it can start slowing down until it reaches 0, then comes back down. So it's thrown at 20 meters per second, right? And then now they want you to calculate the maximum height, right? They want you to calculate the maximum height that it will reach. So we need three things here, right? We already know we're looking for displacement, which is height, the distance, right, from the, when it was thrown until its maximum height, until the maximum height there. So that's the distance we're looking for, right? So we need to find out three things we're given there. So of course, the first thing we're given there is the initial velocity, the velocity that before, right? So which it was thrown upwards, so which is 20 meters per second, right? So we have our VI. Now, what else do we have? We say that the question stops, so it means some other things are given indirectly. Remember, when something is thrown upwards, when it reaches its maximum height, its velocity is 0. So it means the final velocity is 0, right? Because we have the initial velocity, it was thrown at 20. When it finally reaches the highest point, its final speed will be 0. So VF is 0. Then what is another thing that is directly given? It's the acceleration. So the acceleration there, which is 9.8. But now, before I even did this, I'm supposed to choose my direction. So I'm going to choose upwards as positive, right? So this is going to be positive because it's upwards, right? It's thrown upwards at this speed. Now acceleration is always downwards when something's on free fall. It's always downwards, right? So it means that acceleration will be negative this time, negative 9.8 meters per second squared. Now, why is it negative 9.8? Because acceleration due to gravity is downwards, right? That's why when there's no force acting on the object will keep going downwards until it meets a surface that will balance the force, right? So that's what's going on here. So it will keep going downwards because it's accelerating downwards when it's on free fall. Now, the acceleration is downwards, so that's why it's negative. The velocity at which it was thrown upwards, so it's going to be positive. Now I have to look for the equation of motion that has got these 3 plus what I'm looking for, right? So we're looking for the distance, right, which is delta y. So delta y, which is not known, we want the equation of motion that has got all these 4 stuff, right? So if you look at the equation of motions there, right? So in this equation of motion, let's check for the things that are given, the 4 things that are given. Let's check which one has the 4 things that are given. So I want to find the one that has got VI, VF, A, and delta Y. Alright, so this one has got VF, VI, A, and delta T. Well, we're not given time here, so we can't use it. This one has got VF, VI, A, and delta Y. Well, it's equation number 2 again, right? So let's use it. So of course we'll use this one. So let's substitute. So we have got VI, which is 20, right? So we're going to say 20 squared. And then VF, which is 0, right? So VF is 0, 0 squared. And then here we're going to have times 2 times negative 9.8. And then here we're going to have delta Y. Alright, so we substituted this information. So remember, every time we do vertical projectile motion, before even the calculation, choose a direction, right? If you choose up as positive, it means everything that is going down should be negative, right? And if you choose down as negative, everything that is up is positive. It's just up to you how you choose, right? So yeah, that's how it is. If you choose down as positive, everything that is going up will be negative. So up to you. So always choose the directions. And whenever we're calculating time, time can never be negative. If you have a situation where your answer is time and time is negative, then there is an issue there. Alright, so let's continue. So of course 0 squared, when I have 0, 20 squared is 400, right? and then this is gonna be 2 times negative 9.8 is actually negative 19.6. This number came out a lot, so I'm used to it. Negative 19.6. So we just take we can take this to the other side so that it can be positive. So positive 19.6 delta y, right? Let me just write it clearly. Remember here we're at negative 19.6 delta y, right? I just multiplied this and I have that. So when you take this to the other side, we're going to have it as positive, and this is what we're going to have there. So we're going to divide both sides by 19.6. When we divide them, we're going to have delta y is equals to, let me just check that, it's going to be 20.41 meters, and there, that's what we have, right? So that's what we have there. So, and because it's delta y, its displacement is also vector, right? So we have to specify the directions, right? So this is positive, and we chose up as positive, so we can say upwards. But now they ask for the maximum height. It means they're asking for the distance and not the displacement. Then on the next line, you can just say 20.41 meters. You can say the height is 20.41 meters, right? Because there's a difference between speed and, there's a difference there between distance and displacement, right? Displacement is vector, it has got magnitude and direction, right? While distance doesn't have direction, so distance is scalar. So here is displacement, right? So you have to specify the direction. So here it was upwards because we chose positive as upwards, right? Upwards as positive rather. And then now we did that, and then on the next line you now have to say the height, right? The height is that, so you have to explain to them that the height is that. So this one doesn't have direction because its height is actually distance, right? So it's not displacement. I hope you get that. So that's level 1, right? On the next video, I will do the next level. So for my students, you guys will practice the activities that I'll give you, right? And then we'll deal with level 2 on the other video. So we'll deal with all situations.